In this video, we're going to go through converting between moles and particles. So two questions you probably have. What's a mole? What's a particle? Well, a mole is a word that you should associate with Avogadro's number, which is 6.02 times 10 to the 23rd. That's the conversion factor that we're going to be using here to go between moles and particles. The other question you have is, what's a particle? Well, that's a fantastic question. Particles are atoms, molecules, or just particles. And this is really important. Moles are not molecules. Moles are not molecules. They're not the same thing. So when we go to write out our conversion factors, like if I'm using moles, I'll put moles over whatever the number is. If I'm using molecules, I'm going to write out the entire word so I don't confuse them. So again, moles are not equal to molecules. So when we write out conversion factors, do not get them confused. So speaking of conversion factors, let's look at an example. Now these are actually easier than converting between moles and grams. So the first example says, calculate the number of particles in 2.0 moles of carbon. 2.0 moles is going to be our given. So 2.0 moles of carbon. Let's write out our conversion factor. Like I said previously, we're going to use Avogadro's number. Because remember, in 1 mole, there's always 6.02 times 10 to the 23rd, whatever. So in 1 mole of carbon, we have 6.02 times 10 to the 23 particles of carbon. Okay. The hardest part about these types of problems is putting it into the calculator. So I have a TI-84 up on my screen here. The smaller TI scientific calculators function pretty much the same. So I'm going to put in 2.0 times 6.02. Now there's a couple ways to do this. I'm going to show you both ways. So the preferred way is using the E button. So I'm going to press second, and then I'm going to go find the EE button. So I have to actually press the comma, which is, if you look above, the EE. And then I'm going to put in 23. So that EE is times 10, and then any number after it is the exponent. So let me show you what I mean. So if I type in 2.0 times 6.02 times 10, and then I'll use the caret key, which is also for exponents, 23, I get the same number. So it saves you a little bit of trouble if you use the E button rather than having to type out the whole thing times 10. Okay, so I recommend using the E button if you can. It'll just make things a little bit easier. So let's write out our answer here and let's round. So we get, we got, let's see, 1.204 times 10 to the 24. Because remember that E is 24, or sorry, times 10, and then any number after that is the exponent. Okay, in our original number here, 2.0, that is 2 significant figures. So I want to round my final answer to 2 significant figures. So it will be 1.2, don't forget that, 1.2 times 10 to the 24th. Okay, that is 2. Oh, let's not forget our units. Particles of carbon. Remember, our units need to be diagonal from each other so they will cancel out. The units that don't cancel are going to be our units in our final answer. Okay, let's do another one. So notice we did not need the molar mass here at all. We're always going to use that same number, Avogadro's number. Calculate the number of atoms in 0.5 moles of oxygen. So 0.5 moles of oxygen. Let's write out our conversion factor. So in 1 mole of oxygen, we have 6.02 times 10 to the 23rd atoms, in this case, of oxygen. Okay, so let's type this into our calculator. So 0.5, let's try that again, 0.5 times 6.02 second EE 23. So I got 3.01 times 10 to the 23rd. All right, in our original number, 0.5, that is only one significant figure. That leading zero does not count. So when I go to round here, my answer would just be 3, or 3 dot times 10 to the 23rd. And then my units will be atoms of oxygen. All right, not too bad, right? Okay, now let's go the other way. When we go the other way, it can be a little tricky. Calculate the number of moles in 2.4 times 10 to the 23rd atoms of beryllium. So let's write out our given. So 2.4 times 10 to the 23rd atoms of beryllium. And let's set up our conversion factor. All right, so since the atoms are in the numerator here, they need to go down in the denominator here. So instead of writing our Avogadro's number on the top, it's going to go on the bottom down here. So 6.02 times 10 to the 23 atoms of beryllium. So that's how many atoms of beryllium are in 1 mole of beryllium. Okay, now something cool that you can do with scientific notation is you can cancel out the times 10 to the 23rd if it exists in the top and the bottom, just like we cancel out units here. You can only do that if they're the same. So now this is really easy to put in our calculator. It's just going to be 2.4 divided by, now the 6.02 is in the denominator, so we're divide because it's the denominator, 6.02, and I get this decimal. So we get 0.39867 or 39867. Okay. We had 2 significant figures in our given. So we're going to underline the first 2 significant figures and then look at the third. So this is a leading zero. Remember, that doesn't count. So 0.3. Okay, now this one's a little tricky because if we round up, the 9 would make this a 4. Okay, and we want 2 sig figs, so I'm going to add a 0 here. Okay, don't just write 0.4. You've got to include that 0 to make it 2 sig figs. And then my units will be moles of beryllium, because those are the units that we didn't cancel out. All right, let's do one more. This one's going to be a little harder. It says calculate the number of moles in 5.6 times 10 to the 22nd atoms of sodium bicarbonate. All right. So let's do 5.6 times 10 to the 22nd atoms. All right. And then sodium bicarbonate, I'm going to write out the chemical formula. It's NaHCO3. You could have written out sodium bicarbonate if you wanted to. All right, and then let's make a fraction. Just like in the previous one, our 6.02 is going to go in the denominator because this is atoms, so this needs to be atoms. That's how many atoms are in 1 mole of sodium bicarbonate. All right, now in the last problem, we were able to cancel out our powers because they are the times 10 because they were the same and they were in the top and the bottom. This time, not so much. So this time we're going to have to type them both in. So take a deep breath. 5.6 E E22 divided by 6.02 E23. You do not need to use parentheses here. You just type it in like that and hit enter. Okay, so let's see here. We got 0.0930. 2 sig figs? No, no. So we start underlining here, and then we look at the next number. So my final answer would be 0.093, and then my units will be atoms of sodium bicarbonate. Oh, sorry. Our units were not atoms, they were moles. Moles of NaHCO3. Maybe I should actually cross off the units, and then I wouldn't get confused. Okay, so there is our final answer. All right, and that's how to convert between moles and particles.